Hey guys, today we're going to take a look at some different diagrams that have both complementary and supplementary angle relationships in them, but they're missing a variable. So we're going to work on writing some equations to solve for the missing variables. Let's go ahead and get started. All right, for our first example, we have a set of supplementary angles. They are supplementary because they are on a straight line, which means that they add to 180 degrees. So for this equation, our end goal is that we want it to equal 180. Now we need to figure out what needs to equal 180. Well, it's the sum of the angles. So that means when I take this angle and I add it to this angle, they have to add up to a total of 180. So that means I'm going to have 4x plus the 50 from my other angle is going to equal the total of 180. So now all we need to do is solve this two-step equation. We're going to subtract 50 from both sides. That's going to leave us with 4x on the left side. On the right side, we're going to have 130 left. So that means 4 times something needs to equal 130. That means I'm going to divide by 4, and so we're going to get that x is going to equal 32.5. Okay, this is really important here to note that x is equal to 32.5, not the entire angle that contains the x. So over here, this side is not equal to 32.5, just the value of x's. If we wanted to go ahead and solve to figure out what that angle is equal to, we could substitute 32.5 in for x and take 32.5 times the 4 to go ahead and figure out that this angle total is 130. All right, for our second example, we have a complementary angle relationship here, which means that they are going to add to 90 degrees. So our final goal here says that they should equal 90 degrees. Now I'm just going to take the two different measurements that we have of these angles. So of our first one, we have 2x, and I'm going to add that to the second angle, which is right here, which is just x. So we have 2x plus x equals 90. So when we need to go back to our combining like terms, 2x plus another x makes 3x. That's going to equal 90, and then I'm going to divide both sides by 3 to get x by itself. And so x is going to equal 30. Again, here it's important to note that x is equal to 30. That means that this angle right here is going to be 30 because it's just x. But this angle here is 2 times x, so it would be 2 times 30, which means that this angle is going to measure 60 degrees. All right, our third and final example looks a bit more complicated because you see a lot of numbers, but the concept is exactly the same. The first thing we need to do is figure out, is this supplementary or complementary? If you said supplementary, you're correct. It is on a straight line. So our final goal is that it's still going to add to 180 degrees. Now we're just going to take the two labels from the different ones and we're going to add them together. So my first angle is right here. That means that it's a 2x plus 10, and I'm going to add that to the other angle on the other side, which is x plus 26. So I'm going to add x plus 26, and that whole thing needs to equal 180. So now it just comes down to solving that equation. We're going to start by combining like terms. So I have 2 x's here and another x. That's going to make 3x. I have a 10 and a 26. I'm going to add those together to get 36, and that's still going to be equal to 180. Now I'm going to go ahead and subtract the 36 from both sides. We're going to have 3x is equal to 144. And now I'm going to go ahead and divide by 3 on both sides. And I'm going to grab my calculator. 144 divided by 3 is 48. So I'm going to get x is equal to 48. Again, keep in mind that means the x is equal to the 48. If I wanted to solve for the actual angle size, I'm going to have to substitute it back into the equation for each individual angle.